This unit is about the interaction principles as a basis for the design of interactive systems. It covers them to a certain extent, and in the next unit we will add further important details about them. Here you see the learning objectives for this unit. This was the overview diagram in the introduction to what we use as a basis for designing solutions for interactive systems. And now we're going to cover interaction principles. And let's start off by first defining what exactly an interaction principle is. It's a general goal for the design of useful and usable user-system interactions. So general means always applicable, and the topic is the user-system interaction, so anything that happens in the user interface, you could say. And the most important note here is that interaction principles are not bound to any specific technology or method. They are valid for any interactive system that you can think of. It doesn't matter if it's hardware or software or just a service or a combination of anything of that. It doesn't matter if they are implemented in a certain technology. And that is exactly the power of the interaction principles. And at the same time, it results in the interaction principles being rather abstract. And you will see that probably in a minute when we go through them. We will follow an international standard which defines exactly 7 interaction principles. And the interaction principles are generally accepted and always applicable. So they are general, basic principles every design solution should go by, and that are especially important for good usability. The standard we are following is the ISO 9241 Part 110. And we're going to go through these 7 interaction principles now, one by one. I'm going to provide you with a definition and some details so that you can understand them and distinguish them also, hopefully. And I'm also going to give you an example that goes through for all these interaction principles, and that is the interactive system car. So imagine you have a car as an interactive system. You've probably drove one, or at least have been sitting in one when somebody else was driving. So you probably have a rough idea of what a car is used for, what the task is that you can perform with a car. And the first interaction principle that we will talk about is called suitability for the user's tasks. So the user can adequately perform his task, it's what it says here. Or more precisely, the interactive system supports the users in the completion of their tasks. That is, when the operating functions and the user system interactions are based on the task characteristics rather than the technology chosen to perform the task. So the system is well suited to use it to perform certain tasks. The input and output matches what you need for the task. The steps that you can take or you have to take match what the task requires. And the user is not disturbed by any unnecessary steps that the technology requires. And for this example of a car, you can imagine you can drive the car, and you do this by doing the following steps. The vehicle recognizes that you are authorized to drive the car. Then you select whether you want to drive forwards or backwards. You select the direction in which you want to drive. You select how fast you want to drive, and so on, you could say. And this is what you would expect when you think about the task of getting from point A to B rather fast by using this car. And maybe you would note that what I've not included in this listing is to turn on the engine. This is something that the technology actually requires you to do, which is not necessary from the pure user's tasks point of view. Or to give you a little bit more extreme example, if you imagine you had a car where you are required to test the steering by rotating the steering wheel completely from one side to the other before you are allowed to take off. This would be something that would not be suitable for the user's task. So this would not be seen as necessary when just looking at the task at hand. So that is this topic of suitability for the user's tasks. It's a very basic interaction principle. The second one is called self-descriptiveness. It is defined as the interactive system presents appropriate information where needed by the user to make its capabilities and use immediately obvious to the user without unnecessary user-system interactions. So you could say the user recognizes where he is in the interaction with the interactive system. He recognizes the system status, and he knows what he can do here now and how he can do it. That is self-descriptiveness. What is not meant with this topic here is, for example, speaking the user's language. So using terms that the user understands. That's something else, which we'll come back to in the next interaction principle, which belongs more to that one. So this is really only the user recognizes where he is, the system status, and how he can continue. To take that example of a car again, you can recognize if the car is switched on, so if it's ready for driving, meaning is the engine running. And you can recognize in what directions you can drive. For example, you can drive forwards or backwards. Now imagine you have a very innovative new type of car which is also capable of driving sideways. Then it would be a requirement that belongs to this interaction principle of self-descriptiveness that the user must be able to recognize that the car is capable of driving sideways. And then how can I do that? How can I set some setting or something to make the car drive sideways? Another topic that belongs to this interaction principle of self-descriptiveness is the whole thing of navigation aids. So making it clear to the user at all times where he is. Something like a breadcrumb or simply a cursor where the user recognizes if he now touches the keyboard and presses a key, where does this key press go to which field or to which area on the screen. Or for example, the concept of menus, having one place where all function execution possibilities are gathered so that the user can overlook them and knows which ones are available and how they can be executed. So that is self-descriptiveness. The third interaction principle is called conformity with users' expectations. This is defined as the interactive system's behavior is predictable based on the context of use and commonly accepted conventions in this context. So, to say it a little bit more casually, it behaves and displays as expected by the user and comprehensible for the user. And as I just said, this topic of speaking the user's language belongs to this interaction principle. So conform with the user's expectations, you speak his language, things behave the way he expects it to be. The whole topic of consistency, for example, belongs to this. So if you have a drop-down list which has a certain interaction type where you have to click to open the list, and this behaves always the same wherever you go in an interactive system, then this is conform with the user's expectation. To give you an example of conformity with users' expectations for this interactive system of a car, I once worked for a while in Japan, where cars drive on the left side of the road. And when you rent a car in Japan and sit down behind the steering wheel, then you will recognize that a lot of things are actually how you would expect them to be. So for example, the foot pedals are exactly how you would use them in other countries like the US or Germany or in the UK. So the right pedal is for gas, the middle one is for the brakes, and the left one is for the clutch. But the levers behind the steering wheel are switched. So the lever for the windscreen swiper is on the right, and the lever for the turn signal is on the left. So when I started off the first time with a rented car in Japan, and I wanted to make a turn, then I always set off the windscreen wiper instead of actually putting on the turn signal. So this was not conform with my expectation as a user. These three interaction principles, the first three ones, I would say are very basic and very important to get right at first. But there are 4 more interaction principles that we will cover now. And the first one is called Learnability. The user is supported in learning how to use the system. Or more precisely, the interactive system supports discovery of its capabilities and how to use them, allows exploration of the interactive system, minimizes the need for learning, and provides support when learning is needed. To give you an example with a car, imagine you have a rather new car which has an autopilot function, where the car runs in a learning mode, if you want it to do that, where what is happening is explained to the driver while driving. This would be something that supports learnability. The next interaction principle is called Controllability. The interactive system allows the user to maintain control over the user interface and the interactions, including the speed and sequence and individualization of the user system interaction. Or as it's given here in the presentation, the user can control the direction and speed of the interaction and can individualize the UI. An example of controllability, or also the missing of controllability in a car, would be that you are able to control the speed of the windscreen wiper and its sensitivity. So there's a rain sensor in the front of the car that senses how much rain is dropping on the windscreen, and the windscreen wiper then adapts its speed to the amount of rain, and you are able to control the sensitivity. So if you even want to have the smallest drop be wiped away or not. And I actually own a car which has such a rain sensor where the sensor sensitivity to rain is very often either too high or too low, and it's not really controllable by me, by the user. So the interaction principle of controllability is not followed here. The 6th interaction principle is called Use Error Robustness. The interactive system assists the user in avoiding errors, and in case of identifiable errors, treats them tolerantly and assists the user when recovering from errors. So we have different sub-aspects to this. The first one is that errors are actually avoided. The system actively helps the user to avoid making a mistake. The second is that if an error is made, that the system helps or informs the user first and foremost, and then helps the user in recovering from the error. And the third one would then be to provide what we would call error management. So if you, for example, imagine a software that helps you do your tax declaration, then you often enter a lot of data first, and at some point then you do some checking on the data that you entered, and then you get a whole bunch of inconsistencies, or you could say errors, and the system then helps you to overlook all these errors and one by one switch to the specific view in which the error took place, where you then make changes to your entries. And another example for this interactive system of a car: if the engine stalls, so the engine stops because, for example, you didn't give enough gas, then the car automatically restarts the engine. So it detects the error that was happening for whatever reason, and then automatically restarts. This would be a part of use error robustness. And the 7th and last interaction principle is called user engagement. This is defined as the interactive system presents functions and information in an inviting and motivating manner, supporting continued interaction with the system. Or in short, you could say the system is inviting, motivating, and trustworthy. Trustworthiness is one of the sub-aspects of user engagement. And examples of user engagement when looking at a car would be the aesthetic appearance of the car, so that one is keen to drive it, or the firm sound of the door closing on a Volvo. The Volvos were in former days called the tanks of the streets. These were very safe cars to use, and the sounding of the door was actually something that is created, that is designed by the designers of the Volvo cars. And this would be an aspect of user engagement that is implemented here. Or a modern software-controlled car displays a message that says, the operating system has been updated. Would you like to learn about which functions have been changed or added based on user feedback? So this has something to do with user involvement, which is one sub-aspect of user engagement. So these are the 7 interaction principles from the ISO 9241 Part 110. In my professional life as a usability engineer, whenever I do a usability inspection or usability test and I come across a usability problem, then I check which of these 7 interaction principles are probably not observed in this interactive system. And in the last 20 years, I have never come across any usability problem that I could not associate with at least one of the interaction principles not being observed. So I personally would actually claim that this list of interaction principles is probably complete, which is not a claim that the standard makes, but I would invite you to check by yourself whenever you come across an obvious usability problem to see if you find an interaction principle from this list here that is obviously not observed. And if you find a usability problem that you cannot associate with one of these interaction principles, then please let me know and I'll be very interested to hear about it. This finishes this unit on the interaction principles. In the next unit, we will continue talking about interaction principles and then go into a few important details for each of them.